So we just finished talking about area of a sector, which is this one. Now we're going to talk about area of a segment. How you find that is, so if we're looking at this picture on the right, we're going to take the area of the sector OED, so that would be this whole thing. And I'm going to then take out the area of triangle OED. And that's going to leave me with that area of a segment. That's what we call a segment of a circle. Okay, so this is how I'm going to do two examples to help us find the area of a segment. So it's based on finding the area of a sector, and then you're going to subtract a triangle. All right, number one, it says the radius is 8, and I want to leave it in exact form. So if the radius is 8, I want to find the area of this whole sector, and then take out the area of the triangle. Okay, so here's my plan. Area of a sector. So this 90-degree angle tells me that I want 90 out of 360 times the radius squared times pi. So I'm going to take 90 divided by 360 times 8 squared. And I get exactly 16, so I don't have to turn it into a fraction. So 16 pi equals the area of the sector. Now I need the area of a triangle. So the area of triangle AOB, it's a right triangle, and I know all radii are congruent, so the base and the height are 8, is going to be 8 times 8 divided by 2, which is, I believe, 32. Let's just check. Yep, 32. So I got 32 is the area of the triangle. So again, so I found the area of the sector, this whole thing. And if I take out or subtract the area of the triangle that I just found, I'll be left with that shaded region. So final answer, especially if it wants it in exact, is 16 pi minus 32. And you leave it just like that. That would be your exact form. If it wants it approximate, you're going to put it in your calculator just like that with the pi. 16 pi minus 32. I'm going to get about 18.27 is my approximate answer. But we'll typically leave it in exact. I just think it's nicer. It's less decimals, less rounding for us to deal with. Okay, let's look at one more example of a sector. And this one wants us to round to the nearest tenth, but we're always going to round at the very, very end. Okay, it keeps it more accurate. Okay, so plan of attack is area of sector minus area of triangle. So the area of a sector is the number of degrees, the part, over 360 times the area, and the radius is going to be 6. So it's going to be 6 squared pi. So 60 divided by 360 times 6 squared. I got 6 again, so that's really nice. So I got 6 pi as the area of the sector. Now the area of the triangle gets a little tricky here, so I'm going to redraw it off to the side so I can see it a little bit better. You don't have to do this, but this just helps me. So I've got my 60-degree angle in here, which actually makes every angle 60 degrees. Because the opposite sides are congruent, that means the opposite angles are congruent, and this makes it an equilateral triangle. So in order to find the area of this triangle, I know both sides are 6. I'm going to go ahead and make a height in here, drop the altitude, and since this is an equilateral triangle, because the angles are all congruent, this is going to be 6, making each side 3. So now I'm going to go ahead, I can do one of two things. I can do the Pythagorean theorem, or I can do some SOHCAHTOA. I'm going to do the Pythagorean theorem first and do 3 squared plus x squared equals 6 squared. And then if I reduce this, it's going to be 3 root 3. All right, so that's the height. So this is a lot of work here. So that's the height of that. Now to find the area of the triangle, it's going to be the base of 6 times the height of 3 root 3 over 2. So this is going to be 6 times 3 is 18, which is 9 root 2 when I divide it. So final answer in exact form is going to be 6 pi, that was my area of the sector, minus 9 root 2. which was the area of the triangle. And then since the question asks for it in an exact form, I'm going to put it in my calculator just as is. So notice how I didn't turn the height into a decimal because it will throw your end answer off. So try and keep it in exact form all the way through the problem until the very, very end and then round it. So I'm going to put 6 pi minus 9 root 2, and I got 6.126, sorry, 1216. And then if it asks for the 10th, that's one decimal place. So it's going to be about 6.1. Okay, so that is the area of the sector. As long as you remember your plan, area of this, I'm sorry, that was the area of segment. So take the area of the sector and then divide and subtract by the area of the triangle. Go for it. All right, level 3, so we're going to start with the area of a sector. So what this means is that we just talked about the area of a whole circle, but now an area of a sector is part of a circle. So it's not the whole thing, so it's not pi r squared. It's a certain fraction of a circle. So if we think about this in terms of what it looks like, okay, so I'll be given a radius, such like this. Let me ask you something here. If I told you that this is a quarter of a circle, what would you do in order to find the area of a quarter of a circle? Well, I would hope that you would say, well, I'm going to take pi r squared and then divide it by 4, okay, because it's a quarter. Perfect, and that's a great answer because it's a fourth of a circle. Now, what if I took that and just divided it in half, so now I have an eighth of a circle? Well, you might say, I'm still going to take pi r squared and now divide it by 8. Perfect. Okay, now what if I said I'm going to make this 3/4 of a circle? Well, once again, I would hope you would say, well, I'm going to take pi r squared and multiply by 3/4. Perfect answer. Okay, so what we're doing is we're taking the area of a circle, but multiplying by the fraction of the circle that we're looking for. How we find that is by the degrees of the circle. So if I take a look at example A, it says the following. It says the measure of arc AB, so that's from here to there, is 160 degrees. Okay, so whether that tells me that's 160 here, this angle inside is also 160. So in a circle, normally, if I'm finding the whole circle, I'm going to take 360 degrees. And I would say, well, that's the whole circle, so that's why I'm going to do pi r squared. If it's not the whole circle, I know that I want to find the area of 160 degrees out of 360 degrees and multiply by the area. Okay, so again, I'm taking the part that I want to find. I'm not taking the whole circle, so it's not 360. And I'm putting it over the whole, so I'm taking the part of the circle that I want to find, the fraction, just like we did with the 1/2 and the 1/4 and so on. And then I'm going to multiply it by the whole area as if I was to find the whole area like we did above. So in our box up here, what I want to write is I'm going to say part over 360 times pi r squared. Which, remember, apple pies are delicious too. Okay, so now if we have this, and it also says PB is 7 in this problem. So all I'm going to do is, and I want to find the exact. So I'm going to take 160 over 360 times pi times the radius and square it. So how I'm going to keep this exact. You're going to put in the calculator all at once. You're going to take 160 divided by 360 times 7 squared. Got ahead of myself. So 160 divided by 360 times 7 squared. You will get a fraction you'll get a decimal that is 21.77777. Turn that into a fraction using your calculator, hit the math, enter button. You're going to get 196 over 9, and then you'll just bring down this pi here. Okay, so again, what you're putting in your calculator is 160 divided by 360 times 7 squared. And then math, enter. And then just bring down the pi. So that's your exact form. And then to get it into approximate form, we're just going to say multiply by pi in your calculator. That will get you about 68.42. Okay, so that is the area of a sector. Let's look at one more example here. If angle SFM is twice the measure of angle J, and angle J is 30. So if angle J is 30, that means SFM is going to be 60. And then FM is 4. So I want to find the area of this sector again. So again, the area of the sector, so I want 60 degrees of the whole circle. And then the times the area. So it would be pi times 4 squared. So to keep it an exact one more time, we're going to put 60 divided by 360 times 4 squared in our calculator. We're going to need about 2.666, and we'll turn it into a fraction. And I got 8/3, and I'll tack a pi on at the very end as my final answer. And then again, to turn it into approximate, we just multiply by pi, and I get 8.38. Okay. So that is area of a sector. We need to be good at that in order to go on to the next thing, which is area of a segment.